Hello folks, greetings. I'm starting a series of videos on math, and this is a specific kind of math which is basically calculus. And I'm going to start with, I know that a lot of you are expecting some of the basics and stuff, and I will do that, right? But right now I'm actually helping out some people, and so therefore I'm using a specific book and I'm going through the book because math, like anything else, that you have a lot of things in the syllabus, right? So I'm just covering what people are expecting right now, and then I'll go back to some of the basics as I move on. And as a rule, again, I'm trying to see if I can make videos that's not more than 20 to 30 minutes. Okay, I'll put it that way, because anything beyond that, people get a little bit overwhelmed. Okay, so to start with right here, I'm hoping in this video I want to cover two things. One is to provide you some idea of what is an antiderivative. Then the other thing that I want to focus on is that given a graph of a derivative, how do I get antiderivative? Okay, and I'll explain all these things um, uh, in simple terms, but that's what I want to cover here. Okay, so to start with, let me switch over to a blackboard. Okay, here's my blackboard, and just pardon me with my handwriting and stuff because this is a tool I'm trying to use right now, right? Okay, so let's start with the what is an antiderivative, or what is anti-differentiation, right? Obviously, anti-differentiation is the process of finding something, and antiderivative is what you're finding. Okay, so I'll give a simple example, then you will understand very clearly. So you are trying to find the derivative of x. Let me see, let me put a color here. Maybe I'll start with white, like chalk piece. Okay, so you are trying to do, let's say that you want to find the derivative of x square. Okay, so of course you use the notation d of x square by dy. Okay, what is that? Okay, if you know how to differentiate a function, you know clearly that for a function like this, it's a very simple function. It will be, if you see the formula is, if you want to find the derivative of something x to the power of n, then that is equal to n multiplied by x to the power of n minus 1. Okay, that is the formula. So therefore, in this case, it will be 2x. Everybody agree? Because it's 2 into x to the power of 2 minus 1, which is x to the power of 1, which is x. Okay. Okay, so I took a very simple function and I found the derivative for it. Now, I'm going to take another very, very similar function. Okay, so if let's say that I want to find the derivative of x squared plus 41. Okay, so I want to do the dx squared plus 41 by dy. Okay. Okay, here again, what is the derivative? Well, derivative of one term plus another term is actually you need to find each derivative separately, right? So derivative of x square, differentiation of x square is 2x, right? Which we know, just now we found out. Plus, what is the differentiation of the constant 41? It will be 2x. Correct? Okay, so why I came up with these two examples is, you can see that the derivative of two different functions will end up with the same result. okay? And this is useful when we think about antiderivative, okay? So antidifferentiation or antiderivative is that somebody might say that, hey, the derivative of a function is 2x. Can you find the function? You get what I'm saying, right? So in this case, we can say, yeah, I can kind of find the function, because if 2x is the derivative, then I know the original function is x squared in the first case. What about in the second case? In the second case, I know it's x squared plus 41. So the only thing that bothers us is that 41, and you know that x squared plus, it could be 51, it could be 101, it could be 4.56, it doesn't matter. Whatever the constant is, the derivative is 2 of x. So therefore, we can say that if given the derivative is 2 of x, the original function or the primitive function is actually x squared plus any constant c. Doesn't have to be 41 or 51 or 101 or 0, but it is any constant c, okay? So when the process of I have the derivative, I have the answer, and I want to go back to, hey, find the original function. That process is called as anti-differentiation. And in this case, x squared plus c is the antiderivative of 2x. You got it? The derivative of x squared is 2x. The derivative of x squared plus 41 is 2x. The antiderivative of 2x is x squared plus c. Got it? Okay? That's what is the antiderivative. So you're just going back in reverse. Okay. Now, what do you need to go back in reverse? There are some very interesting problems which we'll see later, where finding so I got the derivative, right? In other words, I got the slope of the curve. Hey, given the slope of the curve, can you guess the curve? You see that? And that will help you go in the reverse and find certain things, okay? So you let's say that somebody tells you that, hey, we are trending this way, okay? This is the kind of the trend. Can you find a function, the original function, that makes this trend? Then you go antiderivative, okay? Now, isn't antiderivative the same as integration, as some of the advanced people may ask? Actually, it's not. Integration is a little bit different from antiderivative, okay? And we'll also go back and see what is that difference, okay? Because sometimes, you say that, hey, integration is the reverse of differentiation. Well, conceptually, you're right, but they're completely different from antiderivative. In some cases, they look similar, but they are different, okay? Now, given that I taught you this, I want to, let me clear the screen. I'm going to clear the screen. And I want to give you some notation on how do you denote this whole antiderivative business, right? Now, let's start with, we can say let's say that we have f of x, correct? Now, the derivative of f of x, is, sometimes we denote it as f prime of x. Okay, we just put a dash on the top. So the f prime of x is the derivative of f of x. Okay. Now, what we really need to find out is that given that we have the derivative of f of, that is given, I'm just going to write that down, given f prime of x, find f of x. Okay, that is the problem, that is the process of anti-differentiation. Clear? Now the way you denote it is, for example, in our case we found that the derivative of x squared is 2x, right? So in order to find the antiderivative, the way you denote it is you use the integration symbol. So therefore don't confuse with integration, but it uses the integration symbol. Then you say that the derivative of 2x, right, or the antiderivative of 2x. So for integration, you just use the integration symbol and you just put the function. But here you also need to provide a dx. If you have a dx there, it's an antiderivative. That's all, okay? And that is equal to x squared plus c, okay? Now you will get there's some easy to understand or easy to use formula which we will get to in the next session, but right now this is how we denote anti-differentiation. Okay, this is how we denote antiderivative. Okay, so I've given the definition and I've provided you how I denote it. Okay, now I'm going back to the book, and the book has a definition too. I mean, there's nothing, they are also very, very clear. So the process of finding the original function y equals f of x given the derivative y equals f prime of x is called antidifferentiation. That's what we saw. The original function is called the antiderivative function, also called primitive or integral function. Now, sometimes they may say it's a primitive function, sometimes they may say it's an integral function. Good so far? Okay. Now, I do want to use this book to give you an example of a problem that people may ask you. And the purpose of this particular session is it possible for me to teach you how to solve this problem? Okay. So the problem will be given to you like this. And it's a fun problem, okay? Don't take it very seriously. If you take it very seriously, you'll get into trouble, okay? It's just fun, okay? Think about like, hey, I'm doing some drawings. So they are saying that, hey, sketch the graph of the antiderivative, okay, primitive function, given the graph of the derivative function below, and an initial condition or starting point of 0, 2, okay? So what they're trying to tell is that, hey, they're giving you a graph, okay? And what is that graph? The graph is showing you all the derivative of a particular x or a particular function, okay? It's not a graph of a function. Be very, very clear. It's not a graph of a function, but it's the graph of the derivatives of a function. So they are giving you the graph of a derivative of a function. You got to find its antiderivative, which means that you got to find the original function, okay? And when they give you this kind of problem, you got to understand that you don't have to be very accurate, okay? They're giving you this problem so that you can have an understanding of how is a derivative related to the original function. How is the points on the graph related to the original function, okay? So if you look at this graph, the first thing that you got to understand is, so they have these 2 points, x1 and x2, okay? Now the only thing that we can kind of suss out from this graph is that, hey, if you for example, you take the x1, okay? The y value at x1, at exactly x1, from a positive, so this, if you see that the y value until x1 is positive, right? Then it becomes negative. Okay? So the y value becomes negative exactly at x1. So before x1, it was all positive. After x1, it is negative. Okay? Now, if you think always about that a derivative is a slope. It's a slope of a tangent, correct? And the slope is kind of like a trend line. So I use, in simple words, I use the word trend line. Okay? So your trend line is kind of positive before x1, but exactly at x1, the trend changes. Okay? So until then it was positive, but then it got negative, or the trend line that was going up and up and up kind of went down at x1. Okay? The other thing that the problem says is, hey, you do have a point 0, 2. So that means this graph, or this function does go through the point 0, 2. Okay? So you kind of sussed out two things. Is at x1, so until x1 my graph is sort of positive. That is, my slope is sort of positive. But after that it went negative. Got it? And the same way, and by the way, it also went through the point 0.2. Then again, on the other side, okay, until x2 it was kind of negative, that is, I'm going in the negative trend line. Then it got positive. At x2 it became positive, right? So I'm going to take this graph as is. I'm going to draw this graph and then show you how to find the antiderivative. Okay, let me go back to my blackboard. Okay, and now it's a disclaimer. I am kind of an artist, but I'm not a great person to draw graphs. Okay, so it's and the other thing is, this is just fun activity. You don't have to be caught up with how good or nice the drawing has to be. Okay, so let's start with the problem. I'll kind of draw that in this corner. Okay, so I have the graph, have my x-axis. It's not straight, don't worry about it, or y-axis and my x-axis, right? So and I'm going to do something little different from the book so that you can easily understand what this is about, right? So y is actually f prime of x. Okay, it's not f of x. You got to be very clear. It is the derivative. Okay, and then they had a point here which is x1, and they had another point called x2, and the graph kind of roughly went down. It is a parabola, but it went down like that, and maybe I should have used a different color, but that's okay. And then it went up like that. Okay. Well, the other thing is, well, you know what? Let me draw this a little bit better. This looks like a horrible thing. Let me reset clear the board. Okay, because I realized that I was trying to use use the mouse to draw it, because I do have a pen here. Okay, so maybe I'll use a different color for my axis. Okay, so let me draw straight here. Okay, and then straight there. Okay, and then, as I said, that this is f prime of x. Okay, just so that you're not confused, I'm just going to put y here, and this is of course x. Okay, then we add a point here which is x1, and a point here which is x2, and we had a parabola that kind of went down, and at x1 it became negative y, and then came down to x2, and then kind of became positive y after that. Okay. So, so if this is a question that's asked for you, how do you answer it? Okay. Now I'll give you a simple, easy way. This is my, think of this as, my way of doing it. You might devise some different ways. It doesn't matter. But let's draw the Yarma. Let's draw the x-axis and the y-axis and x-axis. Axis is kind of like that. It's okay. Now, the one thing that we know is, according to this book question, going back to the book question, that my function does go through 0, 2. Okay, so I kind of marked that here. So let's say that if this is 1, this is 2, I don't have to put more than that. So when x is 0, I do have a point in my primitive function, or the original function, there is a 0, 2. Okay. And then I also know that I'm going to have a x1 and x2. Okay. Now, as you can see, that if I look at the derivative, actual derivative, it changes from positive to negative exactly at x1. Okay, so in other words, the trend changes. The trend lines change exactly at x1. Same thing happens at x2. Okay, so all we need to think about is, at x1, the trend line is doing what? It is changing from, so in other words, it's changing from ascending to descending. Okay, so exactly at x1, the graph is changing, my function is changing from being an ascending graph to a descending graph. Okay, just draw a mountain there. And then again at x2, okay, x2, again it is trending from descending graph to ascending graph. Okay, so you kind of draw this out. Okay, one is like a mountain, another is like a pit. Okay, once you draw that out, then it's easy. All you got to do is move your graph so that it touches the point 2, and you kind of draw like that, and you kind of draw like that. Okay, so what this denotes, what this shows, is that, hey, at x1, until x1, things were at a ascending trend. Exactly at x1 it became negative, so it became a descending trend. Same thing, the trend of descending or being negative went on until x2, and exactly at x2, again the trend changed to be positive, which means that it is going up. So that's how you draw the graph. Now, you do want to understand that if you take this graph, that and this is the antiderivative, right? This is the original function. Now, the original function can always have a constant. Got it? So, if you, for an example, in our example, we had the example of x square, right? The y is equals x square. Okay, and maybe we'll use a graph tool to look at what y is equal to x square will look like. It will look like a parabola, right? Exactly like that. So when you have that, then you say that, hey, the derivative we got is 2x. Remember that? We got 2x. Okay. That derivative, if you have that derivative as 2x, it can belong to x squared, It can belong to x squared plus 40. It can belong to x squared plus 50, like that, right? So therefore, even though the graph shape looks like this, it's quite possible that the original derivative function could be same trend but little bit higher because you're adding more constant, or it can also be little bit lower. So sometimes they ask, hey, draw the family of graphs. Then you use the original, first find out the original graph, then use the same pattern on the top and bottom, and there you solve the problem. Okay, so I want to make sure that you understand the problem. We'll try one more example and then you will get it, but let me go back to the book because the book's drawing is a little bit better. So they went through talking about this, how the trends are there, and so they start with at the x-intercepts, the points are turning. Okay, that's the first thing they are talking about. Then they're talking about when x, kind of the value of x kind of is on the x-axis at that some point it becomes less than x1 and then greater than x2, right? So they're just describing what I said, that the trend line is changing like that, right? So at x1 it's turning to descent. So it was ascending until then, and then it was turning to descent, and then it does go through 0, 2, which is what the problem said, and then at x2 again it was all descending down until x2. So from x1 to x2 the trend line was going down, then it picks up and then it goes up. Okay, that's all. So basically the reason why this problem is given to you is to kind of give you in your head as an approximately where does the turning point happen and whether it ascends or descends. Okay, now let's look at another problem, and I'm showing the book because the picture is better, and of course they're now talking about, hey, you know what, there's a family of these trend lines, which is what we also did. Okay, so let's look at your first problem. So here is the thing: for each function graph, sketch the graph of antiderivative function given it passes through 0, -1. So in this problem they've actually given you the derivative graph. You need to find the antiderivative graph, and again, if you would have solved the first problem, you will be, it's very easy for you to solve this, but we will solve it. So the one thing that you got to understand here is that, so in this case there is a point -1. At -1, so before -1, this graph, what is happening here? It is negative. So in other words, before -1, the graph is kind of descending, correct? It is descending before -1, because before -1 it is okay. After -1, it kind of, the graph kind of goes, the trend goes higher. It keeps on going higher until it reaches 2. Exactly at 2, the trend is again negative, which means you're good. So the turning points is a little bit reverse of what we found before, but I do want to take this graph. Let me see the graph and then let me draw that, and now we need to find the answer for it. Okay, so let me go back to my board. Let me clear the board. Okay, I cleared it. Now going back to the book, the other thing that they said is it actually goes through 0, -1. That is, x is 0, y is -1. Okay, good. So let me draw the graph right this side. This is the derivative graph. X-axis, y-axis, sorry, I'm always getting that upside down. X-axis, y-axis and x-axis. Okay, then I'm going to put the same old f prime of x, just to make sure that you all understand that that is the derivative graph. Okay, so the derivative graph in this case, what happened is, it is a parabola. It is still a parabola, but it's like a, parabola that's kind of going down. From down it goes up. Okay, and you have -1 and 2. Okay, so I'm just going to put that. So if this is -1, and if this is 1, and this is 2, okay, so the function kind of, it starts as -y, keeps going up. After -1 it kind of goes up, and then it keeps coming down, and then at 2 it goes again negative, right, in your y-axis. This is your y-axis, this is x. Okay, so now I need to find the derivative, and they said that it goes through 0, -1. Okay, so I'm just going to draw the graph. Okay, and here it is, we are talking about f of x, not f prime of x, right? Okay, and we still have the -1, and we have 1 and 2, and then somewhere here is the 0, -1, correct? So we know that the graph passes through that, and we know that until that is after -1, so before -1, let's start with that. Before -1, the line was trending down. Okay, it was trending down, and obviously my graph does pass through that 0, -1. So my my graph goes through that, but the trend is, the turning point is, I kind of come, if you see that before what do you call, -1, before -1, things were going kind of down. It's a downward trend, and then it was going up. Okay, so you do the pit here, and then we know at sort of 2, things became like a mountain. Okay, that is, the trend changed, and so now I do need my graph to go through 0, -1, but then the trend goes up, and then because before -1, things were kind of like a pit, right? Things were a pit, but then the trend changed exactly at -1. It started going positive, so I'm going up, and then I'm going up and up and up, and then exactly at 2, the trend changes again, so that it goes into descent. So that is the graph you get for that particular question. Okay, so you got to just simply detect the turning points, and then you kind of need to adjust your graph so that it goes through the point that they are mentioning, and you solve the problem. Okay, now again, your teachers will not care about, for example, I get full marks for this graph. Okay, so they don't care about how great your graph looks, stuff like that, but they do care about whether you have an understanding of how the trend changes. That's all it is. Okay, so let's look at one more problem. Let me clear the board for that. Let me go back and look at another problem. So in this case, they're saying, hey, here's a function, and if you take this function this function, the trend line, if you see the trend line, well, the trend line at 3 is positive. Okay, at 3 it is positive. So things are kind of looking up at 3, and before 3 also it was kind of looking up, right? But at 2 things got going down. Okay, and then they want you to draw a graph that is going through 1 comma 2. Okay, so let's see how things happen here. So you're kind of trending up. You're always trending up, right? Even at 3 you're trending up, correct? But exactly at 2 things are trending down. Okay, and your graph needs to go through 1 comma 2, right? It does need to go through 1 comma 2. Now this problem is a little bit complicated because if you take the point at 1 comma 2, right? So if you take the graph at 1 comma 2, so 1 comma 2 is not on the axis. So that's one more thing that you got to remember. Okay, let me go to my so that's 2, 3 and X and Y. Okay, let me go back to my dashboard or blackboard, different color. So I draw the y-axis. Hold on, let me rub this off. I always forget that I'm trying to draw with the mouse, which causes problems. So I draw the y. Oh, it's in, okay, color. Okay, y-axis, there you go, and x-axis, and then this one was kind of like a straight line, right? A linear line. Starts from 3, goes to 2. Okay, so let me put the numbers. So that is 1, 2 and 3 somewhere here, and here you have 1 and 2. Okay, and then this is just a straight line, goes through 3, goes through 2. But in this case, all you got to see is at 3 nothing happens. There's no turning point. The trend is going at the same, the trend is positive. But exactly at 2, the trend sort of becomes negative, right? At 2, the trend becomes negative. Okay, so how do we draw this graph? Okay, so let's see. So this is obviously the derivative graph, f dash of x. Right? So here, let's start with, so I draw my y-axis and x-axis. Okay, and then in this case it has to go at 1 comma 2. Okay, the graph needs to go through 1 comma 2. So I go and say that, okay, that is y's value of 1, y's value of 2, and down here this is the y's value of 1 and y's value of 2. Okay, and also this is interesting because at 2 the graph kind of has a turning point. Okay, so we know that there is a turning point at 2. So let's plot the 1 comma 2 point first, right? There is 1 comma 2 will be, this is 1, x is 1, y is 2. So I'll put a dot here. Okay, and I also know that at 2 things are flopping, right? So until then I had a upward trend, but then things went downward trend at 2. So I create that mountain at 2. Okay. And at 3, the trend was, there was nothing happening, right? So at 2, it was trending, going down, going negative. Okay. And at 3, the trend did not change. That's all we know, right? So we don't care about 3, but we know that this graph actually goes through that point. Okay, so now if you take 3, at the 3 the trend continues to be positive. That's what that graph says. Okay, so I kind of put this going through there and maybe going through there. Okay, so because of that I have my mountain, it kind of goes that way, then it comes down. Okay, that's your answer for that particular problem. Okay, now I don't know how long my recording is going on. Ooh, it's already 41 minutes. It's okay. You know, I didn't teach you a lot of concepts. I'm just showing these drawings and stuff. So let me do one more example so that you're really clear about what we need to do. Right? One other example. Let's take one other example. This is a beautiful example. This is a nice example. And the example is nice because you see that before -4, things were downward trending. Got it? It was downward trending. After that, it was all positive until -1, when again it became downward trending, right? So before -4, it was negative. Then it goes on. Then again at -1, things turn negative. And then you can see that after 3, things turn positive, right? So what kind of graph is this going to be is something that is very interesting, right? So let's take this graph. So it's 1, 2, 3, 4, and then 1, 2, 3, and this is supposed to go through 0, 3. Okay, so let's go back to our blackboard. I'm going to draw how the problem, that is the derivative graph, is going to look at. Y-axis, x-axis, and this is -1, -2, -3, and -4. So this is an interesting graph. And then this idea of 1, 2, and 3. And what we saw in the book is that it kind of is -y until -4, then it kind of goes up, then became again at -1 it goes negative, and then at 3 it just goes up again. Okay, so I'm just going to draw that until before -4 things are in descent mode, right? Kind of goes up there, and then so after -4 things are positive. Then at -1 it gets negative. It goes on like that, and then at +3 things go up again. Okay, and then this is y equals f prime of x. Okay, this of course is x. Again, it's very easy. Once you get a clear understanding, things are very easy. Again, you're drawing your original function, how it should be, how it could be. And one of the things that we got to, and that is always important, first you got to see where does it go through. It goes through 0, 3, right? So this is 1, this is 2, this is 3. So your graph does go through 3, okay, y3, okay. Now of course you're going to mark -1, -2, -3, and -4. And what we know is before -4 things were trending sort of down, right? And then it kind of went, things went okay for some time until -1, things again went down, right? So that is before -4, things were trending down. So there is a pit at -4, correct? That is before -4, okay? Before -4, things were downward trending, and after -4, things went up. And we also know that exactly at -1, things went negative again. So if the trend is, if it is 1, and you know that you need to go through 3, so I'm just kind of going to draw a mountain up there like that, because the trend went negative at -1. Then down here you have 1, 2, and 3. And then what happened is, exactly at 3, you know, the trend was, so you're kind of going down, you're going down, 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 but then at 3, things were again looking up, okay? So these pits and mountains just draw, and of course it has to go through that 3, and that's why I kind of guessed that, okay? So now I'm just pushing this up, pushing this up, pushing this up, coming there, and then going through 3, and then coming down, coming down, coming down, and exactly at 3, again the points turned, and you kind of get, I don't know, what kind of shape is this? This is like a valley and a mountain and a valley, okay? Which is what it is actually. So because you at -4, things were downward going, so there is a valley. Then at negative, and then you went upward, then exactly at 1, the downward trend happened, so therefore there's a mountain. And then you went on to 3, and at 3, there's another valley. Okay, that's your graph. Okay, so that's all it is, and you know, you can continue going this trend more and more. You only had a question, another pattern of question that people might ask you is that, sketch a family of graph, okay? And I don't want to confuse you. When you say family of graph, what you need to do is, you know, and in the family of graph, it doesn't matter. So if you see that sketch the family of graph could represent antiderivative, they're not showing you at which part of y things change, right? So therefore what happens is, so let's take this example, right? If you take this example, see, before x1 things were trending down, at x1 things went up, right? And you got to draw a family of graph, which means that you will be making a lot of u's exactly at x1, right? U, and you don't care at what point things are passing through, because the graph is u, okay? So I hope you understand that, right? The same thing. So if you take x1 and x2, this one, so things were downward trending until x1, then it is going up, so there's a u here, right? And then things were in an upward trend, then went on to a downward trend after x2. So there's going to be a u here and a mountain here, right? So you're going down here, and then you're going up. So you're going up, and then again, everything is positive until the trend changes again, so that you go into a negative mode, right? So, maybe I'll take the second problem here, and I'll still show you. I know it's 50 minutes, but you know what? If I don't show you the family of graphs, then you will get confused. And I'm going to take this, the B graph, and I want to show you how to draw the family of graphs, okay? Let me do that. And again, this is all easy concepts, except that, it took some time because I got to draw. So I'm just going to draw, let me see. Let me draw a straight line, another line, and there was x1 and x2, correct? And then it was like a parabola, a mountain parabola, okay. So it is a kind of a mountain parabola, okay. So in this case, we know before x1, things were of a downward trend, right? Your downward trend, and it doesn't matter where you do it. You can do it anywhere you want, but at x1, this is x1, things turned upward. Got it? Okay. And then things were going upward, and then this is x2. At x2, things became negative, so things went downward, right? So that is kind of the graph, okay? So there's a pit here and a mountain at x2. There's a pit at x1, mountain at x2. Now, guess what? You want to draw a family of graphs, so same trend, right? Same trend. And by the way, you should not do that. You should do that. Okay. That's the family of graph. Okay. So it just shows the shape of the graph. So where you need to put the pit, where you need to put the mountain, is where things transition from positive to negative. That's kind of what you need to understand doing this. Okay. So hopefully this helps you solve these kind of problems. We will continue to I will put more videos probably from tomorrow. I will start putting more videos on antiderivative. But for now, I know it's 53 minutes. Take a break and watch this video. And I'll tell you this, that it's just the drawing. If you are good in drawing, this will happen much faster, okay? And see you all in the next class. Thank you.